Hello, my name is Emeka with SkyCiv, and today I'm going to be showing you how to do a basic residential home design using structural 3D. We're going to go over basic modeling with nodes and members, how to add columns, walls, and eventual supports, add the loading, define section and plate properties, and then eventually analyzing and designing your structure. So to begin, we're going to open a new SkyCiv structural 3D file, and then we're going to go to nodes. I'm going to want the Z X plane to be the flat position. So by defining these. And what I'll do is I'll start adding these and then I'll skip ahead. Okay, so I've gone ahead and defined all the nodes. So I basically have these ones here on the bottom showing the outline of the structure. And then I have some nodes at the top doing the same. And then I have these nodes here, 13 and 14, which will be for a column, which will come into play later. So now that I've defined my nodes, it's important to go and define the members as well. So I'm just going to add the different connections between each of the members. And so to do that, we could draw them with the pen tool, but sometimes it's easier just be exact and define them like this. Okay, so now I finished defining all the nodes. So I basically have, columns, each of the points, and then we have this one cross beam just so we can show specifically how to analyze beams when you're doing a residential home design. So we'll go back. The next step in the process is actually drawing out the walls now. So we've defined our columns now to add our wall. To do walls, we're going to actually use plates. And this is simple enough. It's very similar to how we were defining the columns. We just indicate which are the four corners of each individual wall. And then that's how we would go about defining that. So I'll just go forward and add these real quick as well. Okay, so we finished defining all the walls now, and the next step is just to add supports. So what we're going to do for this one specifically for the column, which is going to be, maybe supporting some kind of structure or some kind of, ceiling member in the building below. However, sometimes you have freestanding columns. We're just going to have a fixed support for that one. But then for the exterior walls to simulate the supports of a wall foundation, we're going to use linear fixed supports. So to do that, we'll go to supports. For this freestanding column at 14, we're just going to do your typical fixed support, apply, and then we'll probably assume that 13 is fixed as well. And then for these ones, though, for the ends of the walls, which are defined with plates, we're going to add a linear line support. So here we compress that, and it's going to ask for, what type. Yes, we want it to be a line. And then for the node IDs, again, we'll just define the length. So for this one, it'll be 1, 2, 2, 3, and now it proceeds. So we'll do that. I'll have to do this for all the walls. Okay, now we've defined all the supports. It's time to move on to the next step. So when we want to begin adding loads, there's a bunch of different kinds of loads we can have. Typically in a residential home, we're going to be experiencing wind loads against the building envelope. We'll probably have some point loads where the roof attaches specifically to the building. And then we might have some distributed loads, which might be some linear loads if there's maybe like a snow load or live load condition, whatever it might be. For this specific instance, we're just going to focus on, we'll just do its example of some point loads and then maybe some area loads on the side to simulate, some wind coming from the side. So we'll go area load. Let's go from 1 to 6 to 12 to 7. And we'll just put it at 1 KSF. And so what's important is right now, if we look at this load, the load directions in the global y-axis, which is up and down, we actually want it pushing in or away from the building envelope. So we'll have to switch to this to global z-axis. If we hit apply, okay, now it's acting correctly. And what I do want to do though is make sure the sign convention is correct. Okay, yeah, so positive z is in this direction, that's the direction, okay, perfect. Then what we'll do is let's add another building envelope here on this side. So that would be 1, 7, 8, 2. This time it'll be in the global x-axis. And we want that in the positive x direction. Okay, good. And then let's just add some point loads so we can see how that would look. And so we're assuming, we might want to do like a distributed load in some cases if we were looking at the load from, say, in particular member. So if we're looking from 7 to 12, specifically that would be a member, and we could define that as a member and then do a distributed load. Or if we have a roof that is just coming by like trusses, let's say, and they're connecting at just the corners and they're coming down and just loading the corners, we could just look at it like a point load. So for this specific condition today, we'll just do some point loads at the corners at 7, 12, 11, 9, and 8. So at 7, we'll do. Okay, so the next step after we've defined the loads is to assign load groups. Then we'll assign the load combinations. And then once we're done with that, we'll be actually able to analyze our design and move to the next step. So let's add load groups. So we're going to define load cases. We're just going to assign load group G just to dead load. Or what I'll do is to show an example for these specific point loads, those would be dead. Let's consider the area loads since they'll be wind. Go LG1. So when we go here, load cases, we'll make LG just the dead loads, but for LG1, let's define that as the wind load. So we'll hit submit. Then we go load combinations, design codes. We'll use ASCE because we're in the US. We use LRFD. Hit display. It'll populate now with the various different load combinations. We hit import. Now it's imported them. So we can go to solve. And so it looks like we missed an important step, and that was for defining the sections and material properties. So it's important for each member and each wall to have a specified material property. Some of them are set by default, but it's also important just to double check and make sure it's defined how we want. So we want all these exterior walls to be, let's say, concrete masonry units, so CMU walls, and then we'll have the actual supports themselves, the columns. Let's make them out of steel or out of wood. Just to kind of make it a little bit more creative, we'll make this cross brace out of steel, and then we'll make the columns themselves we'll make the cross brace out of wood and then the columns out of steel. So let's go to members. So this one is member 9. We're going to make him a separate kind of section ID. And then for the rest of them, we'll just define them as section ID 1. So we can hit apply, go back, sections, go to section 1, section builder. Okay, so for section 1, we said we wanted to make the columns made out of steel. So we'll just choose, we can go American, AISC. We'll just use a default shape. Hot rolled steel looks right. We'll hit submit. Okay, so now section 1 is defined, and then section 2, which will be this cross beam here, we said we want to make that out of wood just to make it something different. So we'll go American again. This time we'll go NDS to define it as wood. We'll go Southern Pine. Just use a basic shape. Actually, let me use LVL beam. Okay, so in this case, this stuff will be populated automatically for us. So if we were to choose, go back to this. So it's a glue laminated structure. We want to make sure the material is wood. Hit submit. Let me go back to the model. So now all the materials have been defined too. And then let's just double check for the plates as well. We said we wanted them to be made out of concrete. So currently they're material ID 1, which when we look at it is structural steel. So we actually want them to be made out of, let's go number 4. So we'll go to this menu here and we'll make sure with material ID here. All of these are 4. Put this extra one, hit apply. Okay, now when we go back, we go solve. all those materials have been defined now. And then the next step in the process, now that we've done that, is analyzing our design and printing a report, and then using the design module, member design module, to finalize our design as well. So if we were to go to reactions, moment, displacement, we can start seeing how this is impacted by the loads. We didn't analyze for buckling, so that won't show, but we can start seeing how building's impacted by the design. If we wanted to print a report, we would just simply go to report here. We can select all or none of the load combinations we want to analyze. And we want to look at the different load cases, envelope cases, etc. And we can, if we want, you can pretty much select anything we want to include in the report here. Really, individualize what we want, how we want the report to print. And when we're done, we just hit create report, and then it'll actually start regenerating the report in the background here. And so we can also always go to, and so this is how the final report looks like. You can view the different load combinations, different node reactions, etc. And then as we can be even broken down into the different load cases. So there was like wind, and then we had LG, which was load group 1, which was just for the dead load. We can look at them, the mins, maxes, etc. Okay, and then if we want to go to design here, we can go to, we'll go change module, member design. We did have some steel members, and we had the one wooden member. So we'll actually look at the steel members. We'll go LRFD, AISC, hit start. And this will launch the member design module, which will help us design the individual members itself. But once you've got here, you've pretty much finished designing your structure. You can look at the different members, check to see if they fail or are able to adequately manage the stresses of the design. So it looks like one of the beams passed, the rest of them seem to fail. And so in this scenario, we'd have to be able to go back and say, okay, what specifically is failing in this particular condition? Okay, if it's failing here because of the slenderness, okay, then we have to modify the slenderness to be able to make sure that it's better. So we might have to shorten the height of the beam or add some bracing, etc. And so what we can also do is use this designer beta feature, which is still in the beta, but this will help you optimize the size and the shape of the specific members as you go through your design. So at this point, what you would do is you can go back to model, optimize your design to try to get it better and to make sure that the member has adequate capacity for your actual design. But for the most part, this is how you would go about the process of starting from nothing to designing the basic layout and structure of your residential 3D design. Thank you.